All right. Hold on. All right, move things out of the way. Everybody can see my screen?
Yes.
Yes, okay, cool. All right, so officially, good evening. Welcome to Terratest, your Terraform locally. We're going to use the LocalStack and Docker tonight, and I'm your presenter, Sven Thirion. So before we get started, I just wanted to mention that all of this information, the presentation, as well as the link to the report that we will be using tonight, will be available for everybody. So we'll make it available. So on this page, we have a link to submit questions and topics that actually links to our Google page. So feel free to visit that page and put in any kind of request for presentations that you might have, or presentation that you want to give yourself. So we're always looking for speakers. So if you feel very passionate about something, you don't have to be an expert on it. I'm not an expert on Terratest or Terraform, but I just thought it was a pretty cool tool. So I want to kind of make everybody aware of it and talk a little bit about it and how we used it. So if there's anything like that, or if you have a topic that you feel very strong about, like I think security came up a little while ago, and I think Karlin is actually thinking about creating a presentation around that, just put that into the Google document, and we'll kind of make sure we can either invite someone or have someone, have one of us talk about it. So yeah, before we start, so I planned to today kind of do a little bit of theoretical in the beginning and then kind of switch over to more like a hands-on demo. I'll go through the demo. Everything, like I mentioned, everything will be available for you guys to access and kind of play around with afterwards. So I create kind of like a shell repo with some examples in it, and we can add some more examples today as well. So today's topic, as I mentioned, is about Terratest and Terraform, how to test your infrastructure as a service. So the birth of infrastructure as a service and the subsequent rise of infrastructure as code kind of opened up a new frontier for us QEs to kind of contribute to the quality of the application and systems they run on to ensure stability, availability, reliability, scalability, and so forth. While there are many infrastructure as code software tools on the market, open source Terraform has emerged as one of the prominent ones. This month's presentation will focus kind of on Terraform and how to use Terratest, although you're not kind of linked to Terraform with Terratest. You can use Terratest to test all different kinds of infrastructure. You can test Docker, AWS, and so forth. I'll mention a little bit more later today. So we'll use that combined with LocalStack and Docker, because right now Terratest it's kind of built to test your deployed code in AWS, for instance. So you will have to deploy it with Terratest and it will test it. We are making a small tweak to that setup, so we can actually redirect our calls that would go out to AWS that we're making through the command line, the SDK, actually to point to our local Docker container. And that's a branch that I found in Terratest. Hold on, my boss is calling. The boss of my boss is calling me. Can I put you guys on hold for me?
Sure.
Let me put you on mute. Sorry about this. I'll have to pause it. Sorry for the interruption. Everything is handled and under control. So to continue, so what I mentioned is, so I'm not an expert in Terratest, nor am I in Terraform. So this short presentation is based on a 3-day CI challenge that I had at my current engagement, where we were starting to implement infrastructure as a service using AWS. We were writing Terraform scripts and we're testing them by deploying code. But while this works initially, it becomes increasingly more risky and more impactful as your environment becomes more complex. So and a mistake that someone makes in the code can easily wipe out your environment. So we start to look at how to test this locally, and we used like the 3-day hackathon, which we call the continuous improvement challenge, and tried out Terratest currently at version 0.38, so they're not even officially launched yet. But we must say that while still in its infancy, we were impressed with the tool, which allowed us, in combination with LocalStack and Docker, to vet our infrastructure changes locally. So what is infrastructure as a service? So according to Microsoft Azure Fundamental Certification training, infrastructure as a service is a type of cloud computing service that offers essential compute, storage, network, resources on demand, and is on a pay-per-as-you-go basis. So infrastructure as a service currently makes up about 12% of all business workloads in AWS. It's one of the 4 types of cloud services, along with software as a service, which makes about 24% of the workload. And for software as a service, you can think about Teams, Microsoft Teams, or Office 365. Then there is platform as a service, PaaS, which is about 32% of the business workload. And that's something like Elastic Beanstalk. So it's a lot of tools that are being used by developers. And then there's serverless. So these are kind of the different kind of cloud services. And so migrating your infrastructure into an AAS solution helps you save money and hardware tools and gives you the flexibility to scale your IT resources up and down with demand. And then infrastructure as code is the management of the infrastructure, the networks, virtual machine, load balancer, connection topology in a descriptive model using the same versioning and approach as the development team uses for source code. So similar to the fact that the source code generates the same binary, infrastructure as code generates the same environment every time it's applied. Before we dive a little bit deeper, I just wanted to take a moment to thank our corporate sponsors, Solemn Built. So Solemn Built is a consulting firm specialized in delivering custom-built technologies solutions as a service, helping companies accelerate their digital transformation journey by blending design, product engineering, analytics, and automation. Solemn Built is currently looking for developers and quality engineers of all levels. Manual testers with an aptitude and interest in automation are encouraged to apply. We are currently developing a U-Build, like a university program for people to build up their automation skill before we kind of staff them on a project. So for more information on Solemn Build, please visit solemnbuild.com. And then real quick, before we start, Testaholics Anonymous organizers are David Payne, currently joining us from Atlanta, Georgia, Karlin, Kappala, and myself, Sven. So let's talk about Terraform first. Terraform is an open source infrastructure as code software tool that allows you to manage hundreds of cloud services. It allows you to write like infrastructure as code using declarative configuration files. Those files can be written in HCL, which stands for HashiCorp Configuration Language, or you can use the SDK to write infrastructure as code in Python, TypeScript, C#, Java. And it basically allows you to manage the full life cycle. So you can create new resources, manage existing ones, and destroy the ones that you no longer need. The other thing you can do with Terraform is kind of execute a plan. And what the plan does is it checks the execution plan for configuration matches with the expectations that you have before it kind of provisions and changes the infrastructure. So plan will tell you what resources will be created, modified, or removed. Pete, you had a question?
Are we on a different slide because we still see agenda slide?
Everybody just seeing agenda slide?
Yeah.
Yeah. Oh, I thought you were just reading notes. So.
Okay, let me make a reshare. Thank you for pointing it out. Okay, where is my... Are you guys not seeing the Terraform slide? Or not yet?
Not shared yet.
Why is it?
Okay, thank you.
Okay, sorry. So basically, real quick, so the right kind of allows you to create the declarative files, which kind of specify what kind of resources you want to create, and you can use multiple languages for that. So the plan will kind of look at your execution plan and kind of will tell you what resource will be modified and created, so you can kind of confirm that that's exactly what you want to do. And then apply will kind of apply these plan changes And Terraform kind of is compatible with a multitude of cloud providers, AWS, Google Cloud, Azure, and a lot of different other ones. And then the other command that we're going to take a look at today is destroy, which kind of removes the infrastructure that was created. So this is really helpful for our testing, because we kind of want to create the infrastructure, test against it, and then destroy it again. All right, and then the other tool we will be using is LocalStack. So LocalStack is a mocking framework that allows you to mock AWS cloud services like EC2, S3, Dynamo, Lambdas, with all the same functionality as their cloud counterparts. It allows you to test your cloud applications locally without incurring the cost to spin and configure these services in the cloud. It allows you to test prior to merging and deploying your code, which is something that had a tremendous impact for us in one of the projects I was on, because we were building Lambdas, but we had no way to kind of test these. We had to deploy them. So with this solution, we were able, with LocalStack, we were able to kind of spin up these Lambdas, and they were kind of communicating with each other with the SQS. So we were able to spin up SQS as well and kind of do the full testing locally on our machines. So the same way you test your application code, you can basically use that also to test your infrastructure code. The LocalStack comes in 3 flavors. You have the open source one, which used to be called the community service. This one has most of the APIs that you will be working with. There's also Pro, which has some advanced functionality like Cognito and AIM, so for security and accounts testing. And then the enterprise version is all about like personal support, training, and some specific functionality you're basically looking for. They will help create that for you. Just to give you an example, so these are all of the free services that are available. We have virtual machines like EC2, we have storage like S3, we have messaging like SQS and SNS, we have Lambdas and step functions, certification and secret management like Secret Manager and KMS, and many, many more. So as you see, most of these services are the ones that the developers use nowadays. So there probably won't be a reason why you need to go with like a Pro version or even enterprise version. These are some of the examples. I don't know if you can really see it, but I just want to mention that besides Terratest, there are other tools out there that people might be familiar with. So Teach and Terraform is one of them. RSpec Terraform. So these will also be good frameworks to look at and see if they can help you with testing your infrastructure. But I don't know if you can see, but can people see this? Otherwise, I'm just gonna go over the code that we have for the demo. David, can you see?
Okay. It's hard to read the images, but
okay. Well, I can quickly kind of talk about. So you look here into this test function. You see Terraform directory that's specified. So that's where you basically specify where your Terraform script is. And this one, defer Terraform destroy, means that after the test is done, it will destroy everything that it has created or change everything back what it has changed. And then init and apply, that basically will initiate the Terraform script and then run it and apply the changes or kind of bring up the environment. Something I wanted to call out too is that here, so basically Go is like a wrapper around Terraform. So it has some wrapper functions. Like with default retry error, that kind of handles like timeouts, checks some errors, connections closed by peer that sometimes happens in Terraform, so that automatically retry, so you don't have to build that into your framework. In this example, it basically gets the output after Terraform executed the script, and it's looking for the public IP address. It uses that to generate a URL, and then this will call the endpoint with some retries. So there are about 30 retries with 5 seconds apart, and it basically expects a 200 back with a response body of hello world. So let's now switch over to the demo. I think for the first one, is kind of, so again, everything is available. Afterwards, I make this presentation available, so there's links to all of the tools that we will be using. So we will be using Docker, just a Docker engine. You don't need Docker desktop necessarily. We will be using Docker Compose to spin up our LocalStack container. We'll be using Terraform, of course. And the tool that I'm using is Visual Studio Code. So you can use any tool you want, but we will need Go. And then there's some Go and HashiCorp Terraform plugins you need to install. And I think on the repo, I have the links to those plugins. So you can just click on them and install them in Visual Studio Code. And then we have the repo. So the repo has some instructions, explains a little bit what it is about, and then the tools that you need, the plugins, and then how to install it and how to actually run the test. Real quick. Let me bring up Visual Studio Code.
Could you post that GitHub link in the chat?
Sorry, what do you want to do?
Can you post a GitHub link in the chat? The one that's on.
All right. So let's talk a little bit about the different parts.
Wait, sorry, did you post a GitHub link somewhere? I missed it then. I don't see it anywhere.
Yeah, I'll go ahead and post it.
I didn't post it?
No.
But
Oh, there we go. Karlin got it.
okay. Oh, it looks like I did a direct message to Bindu. I don't know why that happened. Okay. So let's talk about the different parts. So you can basically put everything into one Terraform file, but you can also break it out into different pieces. So in the main one, we kind of have the resources that we want to generate. So in this case, we are creating a policy for the S3 bucket. This is something you don't want to do. Basically, you want to. So basically, what I did is that this particular identifier, which is the user that you will be using, has basically unlimited access. You probably only want to give the access that you need, like listing the directory, get the object, put an object, delete an object. That's probably what you want to do for an S3 bucket. You don't necessarily want to open up everything and allow everything. But that's a policy we will be applying to the S3 bucket. So we will be creating a log bucket too, but we're not really going to use that one. And we will be creating a test bucket. So if you look at the test bucket, we call it test bucket here, but we can actually override that with a variable. And those variables are kind of defined in the variable file. We will be turning on versioning. There's some logging that will happen to the bucket, the log bucket, but we're not necessarily will be using that. We have some tags, and then we'll assign the policy, the bucket access policy. So that's the main one. Let's switch over to the variables. So we have some variables here, like the bucket name. We can pass in the bucket name in our test. So we can validate that when we create a bucket, it actually has the right bucket name. We'll do the same thing with environment. So we have defaults in here. So if you don't specify it, it will use the default names. And then with policy by default is false, but we kind of will create it with the policy. And we'll play around a little bit to kind of show the test passing and failing. We have the provider that basically tells you we are going to be using AWS, and we have a region specified. You can also just use a random region if you want to. We are overriding this region in our test, but this is kind of the default one. So since this is going to be in LocalStack, we don't really have to specify an access key and secret key. So we're just saying mock access key and secret key. And this is the endpoint that we are going to expose for our S3 bucket. Output. So in outputs, when Terraform kind of generates a resource or manipulates a resource, you can actually, as part of that, output specific information. and assign that to a variable. So you can kind of then validate if if the bucket ID is what you expect it to be. There are other ways of communicating directly with the container, not the container, sorry, the services, and we'll go into that as well. And then the requirements are basically just saying that we are using a required Terraform version of 0.12 or higher. And we are using this particular provider for Terraform with AWS. We can go through everything. Okay, so this I want to point out as well. So this is the Go mod and some files. So these are all like the libraries it's going to. What I want to point out is that we will be using Terratest and Testify for like the asserts. Over here, I'm actually overriding the version that I'm downloading with a feature branch. And this is a feature branch that actually allows you to redirect the calls to AWS. Instead of going to AWS, you can then point them actually to your local container. All right, so this is a very simple test that we created. So basically you have your imports on the functions you will be using, as well as the different modules you will be using for your test. In here, we kind of create a name for our bucket. So we have a prefix of S3 bucket, and then we create a random unique ID for it. So we assign it to it. And then later on, we will be validating that the bucket that was created has that expected name. The expected environment is developed. The region, we are creating, just picking a random region. That's probably what you want to do in your test. Since you want to make sure that it works not just in your default region, but in any kind of region that you deploy resources to. If you only have one region, you basically either don't specify it or you set it to that specific region that you would be deploying to. So this is kind of the magic here. We kind of saying that you're overriding the endpoint. So instead of pointing to AWS in the cloud, we are actually redirecting it to our local host on that port that we specified in the provider file. Here you have your variables that we are passing in, so the expected name, the expected environment, and as I mentioned, we want to create it with a policy in our region. So this is to kind of make sure that after our test is done, we are destroying the Terraform resource that were generated. This is the init and apply, where we basically initialize the Terraform script to run, which is the one we saw in the main, and then apply it, which we will be generating like the resources in LocalStack. And then once that is done, once we generated the resources, we will run our tests. So we, in this case, we'll get the bucket ID from that output that I showed earlier today. So this was, we are just getting that bucket ID and then passing on to the bucket ID variable. In this test, we are getting that information. We have to trim it as a little bug right now in this version, in that it comes with the quotes tag. So we have to remove some quotes and special characters. This is one way of doing it, trimming it. I have another one that I will show you later, where we just use contains as an easy way to run it instead of using equal. And then we basically validate that the expected name of the bucket matched the actual bucket that was created.
I have a question, Sven. Just in plain English, I just want to understand, like Terraform is creating the infrastructure, it's creating these 3 buckets, these policies and all of that. So when we are creating this Terratest script, are we actually validating the names of the resources that have been created, or?
Correct. So here in this command on line 55, we are creating the resources, and in 58, we're basically getting the name of the bucket that was generated.
So you're basically running the Terraform script in this Terratest.
Yes, we do.
Okay.
And then another way is basically using AWS SDK. So there are commands there about get bucket versioning that will call out to the bucket itself, and we'll get the version. And there are a couple other ones that I want to go through as well that you can use. A few useful ones. You can kind of say, get a list, for instance, of all of the files that are in there. You can upload a file. You can use the SDK basically within your test to do additional things if you don't have it specified in your Terraform script. Normally you would specify those things in your Terraform script. You can. So in here we get we validate that the versioning was enabled, and then we also validate that the policy exists. So in order to run your test, you will need to spin up LocalStack first. So we'll say I have Docker. Hold on, I got Docker. Sorry, that's some other projects. So nothing is running. So we have a Docker compose file. Hold on. So in the Docker compose file, we basically will get an image from LocalStack. We are exposing certain ports, and then yeah, that's about it. So this is our Docker compose file to basically spin up LocalStack. We'll execute the Docker compose right now. And I'll run it without the -d flag, so you can basically see the logs that we generated.
Should Docker Compose build work for this project first? I'm just
Sorry,
curious.
what?
Docker Compose
You
build.
don't need to build a Docker. So you might have seen the Docker here, the Docker file. You don't need to build the image. So you can just pull that image. This is me just going further and basically spinning up a container for my Terratest and Terraform so that I run the actual test and the Terraform script within the container, and then it calls out to a different container to LocalStack in a different container. So I'm still working on that one. So, but for this example, we are not building any images. We are basically pulling the LocalStack image and just starting it up.
I feel like I did something wrong because Docker Compose up crashed on me.
Yeah, that happened to me as well, David. Like if I'm directly working with Docker image for the local stack, it is working. Like when I'm trying to reach out to localhost 4566, it works. But if I'm trying to do with Docker Compose, it doesn't work. It just hangs.
Oh,
Maybe
mine
some.
just it's different than mine. Mine just fails utterly.
Oh, okay.
It's like it's complaining of like a file not found in directories across the board, which is
And does it tell you which files not found?
looks like it's a bunch of packages it's trying to import. So inside, hold on, let me make sure I'm in the right file. Site packages, Docker transport uni xcon py. Where is this file? There is no such file there. I'm confused. Yeah, it just looks like there was all the packages. It's not able to find them. Let's see, Docker Compose fails on line 3. What is line 3? LocalStack?
Okay.
Yeah, I mean, mine is basically that error. Like that seems to be the main error when I look around.
Is that by chance a like a YAML error? Like you use tabs instead of spaces?
Well, I do like tabs, but let's see. Could it be a switch them? No, mine's set 2 spaces right now, so I have 2 spaces for each tab right now, it looks like. I mean, I'm used to stuff breaking on me, so feel free to continue on.
Okay. All right, so it's starting up. So your infrastructure, you probably can find. Where are you? Just to give you an idea where your infrastructure and where your services are. You get your infrastructure here. You see Kinesis, DynamoDB, KMS, and your services should be in here. So you have EC2, S3, DNS, so quite a few services. This is basically where the services live within the directory. And so let's see if we are seeing services running. Okay. Then so services are running. If you want to see which services are running, you can put in health. Gives you a list of all of the services that are currently running in the services and their status. All right, so LocalStack is up and running. So in order to run the test, so now to run the test, we have to move to our Terratest folder. And then you can run the test just by going to say go test. It will run all the tests that we have. We just have one test. You can also specify a specific test you want to run. You run the test. You'll see that Terraform will be initialized and what region it's using. So in this case, it's using Northeast right now. So initialized, sorry. So it defines all of the resources that it will create. So this is our policy. We have our test bucket. We have a log test bucket and our access policy. So the plan is to add 3 resources. We have no resources right now. So no, 0 to change, 0 to remove. Then that's the output that we kind of requested. So the bucket ID. The user generating is actually applying the code. So it's creating the resources. And it says that 3 resources were added. It puts out the bucket ID. This is the output. And then basically runs the test and then will destroy the resources afterwards, after a test. And then we'll see that the test actually passed. So we can modify the test just to make sure that, let's say that we say we want the versioning to be disabled. We expected it to be disabled. Save, we'll run the test again.
So I have a question. How often would something like this be run? Just when you're done developing the infrastructure in Terraform, you create the test, and then because once it's in, right, you don't necessarily mess with Terraform a whole bunch.
Correct. Yes.
So is that correct? So these tests just sit around and wait until you're actively developing it. You're not like putting it on a regression schedule or anything, right?
I wouldn't, since, well, I would only execute it basically when the Terraform code gets updated or changed.
Okay.
I wouldn't run it all the time. I mean, you're not going to expect anything different. It's just going to pass. So in this case, it failed the test, and it basically will tell you where exactly it failed and what it expected to be disabled, and it was actually enabled. So that's what a failure looks like. So let's do something else. Let's get the actual domain name. And sorry, I'm just going to copy and paste the code, but if you were to, you can do that in the output. There's a command here to get the domain name. So this will run the command S3 bucket, and then our test bucket, and then basically the command bucket domain name, and return it back into the bucket domain name variable. And then let's say we want to do something else. We want to get the region. Actually, we want to validate that it was created in the correct region. So there must be, hopefully my copy and paste will work. Okay, so that's that. And then, so in order to test that for exit, so that's end here. So here, basically, it's the same approach. So we are basically getting the bucket domain name by calling the variable in the output one. And then the expected domain would be bucket ID plus s3.amazonaws.com. It's what we expect it to be. And then we'll do an assert that our bucket domain that we get back from Terraform at the output is the same as the expected domain, and same thing for the region. So same approach. We use Terraform output to get the value for the bucket region variable, and then we'll in this case I'm going to assert that it's going to be US East 1, which might and might not work, meaning it might fail. Let's do this enabled. Test again. Okay, it worked. So, something else I want to quickly go over. So I mentioned that you can run these AWS SDK command. So you need the AWS CLI for that. But let's say that we count this out, so we won't destroy our bucket at the end. So we can kind of play around and connect to it. If I run the test now, oops. Okay, the test failed. Not sure. Hold on, state file either has no active file. Let's change. Let me just check. Oh shoot. Okay, I found my issue. I commented out the init and apply. Of course, it's not gonna work. But I commented out the destroy. Yeah, it didn't generate the resources. Okay. So now the resources are not destroyed, so we should be able to run some CLI commands against it. So one of the things you can do if you have CLI installed, it's AWS, you can specify the endpoint you want to connect to, because otherwise you will try to connect to Amazon Cloud Service. That's the port 4566. So we want to run an S3 command against the S3, and we basically just want to do an LS, see what buckets have been created. So we should expect the buckets to be reclaimed. Hold on.
http://Sven, you're missing / there on that.
Yep. All right.
Yeah, and we can also use AWS local here, right? Because AWS local also works with LocalStack, and it actually talks to LocalStack. We don't need to give that URL here. We can simply say AWS local and just say S3LS.
So you say we don't need localhost in there?
No, if we have AWS local installed on our machine, then we can go with AWS local also. Like when we are using AWS local, we don't need to specify the local host there. That will by default talk to our local stack.
So you're saying this? I don't think our
No, not that one. Let me give in something. AWS local. I'm just putting something in the Zoom chat. So if you see that AWS CLI local, so that's another CLI. So what we need to do is we need to install this on our local machine. So after that point on, you don't have to give the URL there. You can simply say AWS local S3LS, then it will give us the buckets.
Oh, thanks. I wasn't aware of that, so thanks for that. So we got a bucket. So if we want to, let's say we want to just upload and do that as well. We can say S3, we want to copy the README file. And we want to put it into our S3. Okay, so I upload it and just to sure. See. Yes. This should give us the content of that S3 bucket. There you go. There's README. So just let you know that you can interact with that local stack container just like you would interact with a S3 bucket in AWS. And that's kind of what I had today. Let me see. Yeah, this is the commands basically around how to get started and then what to run the test. So this is kind of if you want to run a specific test in your files. And then this is kind of a tutorial that kind of talks a little bit more about Terratest and how you can use it. And that's it. And so are there any questions?
Hi, Sven, I have a question. So very interesting. Thank you very much for your work to present it. Did you try to add Terratest to a pipeline where you automatically run Terratest when something is changing?
No, not yet. So we did this during like a 3-day hackathon kind of thing on our project because we were originally just deploying and then manually validating that things were working fine. So we need something that could do it in an automated fashion. And then we also wanted to see if we can actually run it locally. So we didn't have to deploy in our environments because we didn't have really an environment to play with. We kind of needed to go directly in our development environment. So that's why we want to run something locally. And we haven't put it into the pipeline. So one of the things that we wanted, that's the reason basically why we are generating this Docker file. It's basically, yeah, this is a working on a government project right now, but basically we are kind of building an image and a container where we can actually run Terratest and Terraform. So that's what would be the next step before we can actually run it into a pipeline. We want to be able to run it inside of a container.
Thank you. Sounds like an interesting challenge.
But yes, it shouldn't be too hard. You just basically should, if you have it installed locally on your agent, on your, I don't know if you use Jenkins, whatever, but if you would have installed locally, you should be able to just run it within that agent.
I think it would be interesting to configure somehow to be some of the tests to be part of the Git, you know, and when you commit to run the test automatically locally to detect if you have issues or something like this, that could be very helpful.
I agree. If you're like a CDS guy and you're responsible for the infrastructure and work with Terraform, yes, definitely be useful to run it locally. And then I also used it on a different project, as I mentioned, to kind of spin up our application locally. So not necessarily testing Terraform, but just kind of spinning up Lambda functions and SNS and SQS, and then kind of executing the tests using a local environment.
And then some of the projects that I recently worked, the Terraform script was not run frequently. It was probably just run once the very first time and always run when there is something new getting added. Even now we are using GitLab. So, you know, once I moved everything to Terraform, it was just run once. And if there is any other cloud resource being added, only then the Terraform script runs again. So to the question earlier, I think it's not run very frequently. So maybe Terratest can also be attached to it to be not run very frequently.
I do like the idea of thinking of something like spinning up a Selenium grid with Terraform with testing in your pipeline. That really piqued my interest. I think that would be a fantastic use case.
Mhm.
Yeah, that is very interesting, actually. I mean, one of the clients that I worked very recently, they have like 10,000 test cases that they run in Azure, and they don't have these, yeah, excuse my kids nearby. So they don't have containers to use, or they just run everything on parallel machines. So that was one of our use case to, like, think about containerizing all the tests. But what you mentioned is very interesting, Andrew, to have Grid and Terraform run on that.
Andrew, I was part of a project where we have done this with Ansible some years ago, 2-3 years, and it was working nice in AWS, creating everything and destroying at the end.
I'm very happy I found this group. Thank you again, Sven, for the presentation. This was fantastic.
You're welcome. I'm glad it was useful.
Very.
All right, so just a quick shout out. So we have our meetup group, so you can kind of become a member there, so you get notified about upcoming events. We have our LinkedIn page where we, besides having the events listed, we also discuss articles or write articles ourselves. So Karlin just wrote an article about Terratest and Terraform, kind of going a little deeper into the why behind it. And why do you want something like Terratest? Why do you need to test your infrastructure? So I'll definitely recommend reading that article in Medium. And then we have our Slack group where basically we'll be posting the presentation as well as all of the links. We also have, there's a way for us to kind of communicate, help each other out in case you have questions either about the presentation or just any question in quality engineering. I think it's a great tool for us to kind of help each other become more proficient with questions, roadblocks that we have in our jobs and work, so we can all help each other out. I'm gonna stop recording.